can be explained again by going through the game which I showed you in the very first slide. All right? So if you take a look at the first slide, you can see this kind of game available on the internet website. So in the beginning, when the user click this side, the computer automatically generates an arbitrary matrix, let's say 8 by 8 or 10 by 10, depending on the user selection. And with that original given matrix generated, on the computer screen, you will see there's some non-zero value, some zero value there. And now, assuming you have two players, you have player 1 and player 2. On the computer screen, it will show you, for example, you want to swap a certain equation, let's say equation 1 or node 1. Do you want to swap it with a new equation 1 or 3 or 4 or 5? You can have an option to swap. In fact, you can see in here you have another slide, another picture in here, which tell you this. What is this one? I cannot read clearly here. Let's say that is node number 2. Probably look like node number 2. You want to swap node number 2 with the other node like number 1 or number 7 or number 8 or what? So when you suppose you decide you want to swap node number 2 and you want to swap with node number 7, for example, then in here you say, okay, node number 2, you want to swap node number 7. So if you click right here, then the computer screen, they will give you a new matrix, which we call A star. And with the new matrix A star, just like the original matrix A star, and now you have a new matrix A star. The new matrix A star, by looking at the new matrix A star, you can identify, for example, how many fill-in terms that you have. If the number of fill-in terms that you get from the new matrix A star due to the factorization phase, Cholesky factorization phase, turn out to be less than the number of fill-in terms that you have from the original matrix A, that means your swapping the node, or like moving the chess game, is good. So in other words, if you swap node 2 with a certain node correctly, then the matrix A star will have the desirable feature. That means the number of fill-in terms due to Cholesky factorization of the matrix A star will be a lot less than factorizing the original matrix A. And that is only true if you make the swapping node correctly. And remember, when you swap the node like that, it has the same effect like you say I perm, let's say, of the old node number 2 will become the new node number 7, as an example. This is the old numbering system, and this is a new numbering system. So if you swap the node correctly, the new matrix A star will have a lot less fill-in term. Okay? So through this kind of a game, the user, which can play like a player number 1 or player number 2, if he make a good move, a good swapping the node, then he will be rewarded with some monetary amount. Otherwise, if he make a bad move, like a chess-like game bad move, then the matrix A star may getting worse. In that case, then the matrix A star will have a lot more fill-in term when you do factorization. So if the player makes such a bad move, then he will lose his turn and he will not be rewarded any money. But assuming he make a good move, then he will be rewarded some money, and then the other player will continue to make further swapping the node or come up with a new mapping I-perm strategy with the hope that his new move will further improve the number of fill-in terms when people do the Cholesky factorization. So if you look the last two slides or so, I want to summarize it about this game. The chess-like game that we developed, you can see it by, or you can see and play it by going to the internet website, http World Wide Web lions.odu.edu/tutor, and continue to type Amoha 006, AMOHA 006 / capital F, fill in terms in one word, dot or slash, capital slash, okay, not a dot. Fill in term, everything in capital. Fill in term, plural, and then dot, HTML. So if you go to that website, and then with the instruction on the screen, you will be guided to play the game. So through this game, what we hope is we will be able to help teaching undergraduate or even high school students to understand the so-called reordering process. And remember, reordering process involved with the mapping integer array. And that integer array iperm, basically, you control it through swapping the node during the game, swapping the node. For example, you swap the old node or the old equation or the old row or the old column with the new node number. So this game will help the student to understand the reordering algorithm. And furthermore, in item B, it will help the student to understand the symbolic factorization phase, which means you don't care about the actual numerical value after factorization. You just care about the non-zero term. How many non-zero terms you have, including the fill-in term that you have during the factorization. Also, this game will help the student to go understand the numerical factorization phase. Because as you can see, the symbolic factorization phase is very similar to the numerical factorization phase. And then, finally, not only help you to understand about the reordering algorithm, but through this gaming process, the student may even discover new reordering algorithm. Why do I say that? The reason you can discover the new reordering is because when you swap, let's say, a certain old equation number to become the new equation number, that process is equivalent like getting the integer array iperm mapping that I talked to you earlier. If you swap it properly, then your new matrix A star, when you factorize it, it will have a lot less fill-in term. Okay? And in fact, if you make a lot of good move in here, your strategy, like a chess-like move game, may be even better than the existing algorithm, such as I told you before, reverse Cut-Hill-McKee algorithm, reordering algorithm, or Matis reordering algorithm. So that means it gives you a chance to even discover the new algorithm by yourself. And when we explain about this one, we use a game development. We use a powerful feature offered by Flash computer environment to take advantage of animated sound human voice, motion, graphical color, animation, in order to have more appealing to the game player or the student. In the developed chess-like game that I just described to you, some sort of a fictitious monetary or the game score is rewarded. The rewarded amount of money will be broadcasted by computer animated human voice to the game player. Also, like I told you, if through your swapping the node, like a chess move, like chess game move, if that result in the new matrix A star that have a lot less fill-in term, then the computer will broadcast a congratulation message to the player who discovered the new strategy that is better than existing strategy. If you go to that website, you will see some different matrix size and the different sparsity. We suggest you to select the big matrix size. When I say big here for education, I mean like 8 by 8, and also select a lot of sparsity. So you select that one and you can begin to play the game. And in our example, in our program, we assume that we issue up to a maximum of $1 million to be rewarded to the player who make a good move, like a chess-like game move. And the exact dollar amount rewarded to a particular player, if he make a good move, will be inversely proportional to the number of fill-in term. That means if you swap a certain node, if you swap a certain old node to become a new node number, and you do it the right way, such that the number of fill-in term introduced will be a lot less, then your money awarded will be inversely proportional to the number of fill-in term. And the next player will continue to play based on the best currently available non-zero location. Finally, I would like to acknowledge the support from this NSF grant, where this is a collaborative effort between ODU, Old Dominion University, where I take the lead with the University of South Florida. The co-PI is the Professor Ota Carr, and with Arizona State University. The co-PI over there is Professor Ram Pandiala. Thank you. So this is the end of the lecture. Here is the acknowledgement page.